NMR spectroscopy. Again, there's probably many videos and even online simulators for NMR spectroscopy. What the purpose of this lab is to give you as much hands-on as it can be in an online environment, but some real practical experience prepping an NMR sample, both liquid samples and solid samples, prepping them for NMR analysis, and then the actual operating techniques for measuring and acquiring a spectrum in the NMR room with an NMR spectrometer. And so we know several things from theory for NMR, certainly gone over primarily in class or in pre-lab reading. Primarily, the main things that we look at in proton NMR are going to be things along the lines of its chemical shift, so the chemical shift value, the splitting, which tells you about its environment, the number of hydrogens on neighboring carbons, which is very useful. And then finally, the integration. This will tell you about the number of hydrogens that correspond to that signal. So I won't go through the theory here because we should have gone through that in pre-lab reading and pre-lab videos. But these are just a quick reminder of the things that we're looking for in proton NMR. So let's go to the lab and do some NMR sample preparation. When it comes to prepping samples for NMR analysis, there are two methods depending on whether the sample is a liquid, as we have here for unknown 6, or if the sample is a solid, as we have here for unknown H. Now, the other things that we have present that we need here is some deuterated solvent for NMR. Now, most of the time, deuterated chloroform is the most common, and that's what we have here, but there's also deuterated acetonitrile, deuterated THF, deuterated benzene, many other deuterated solvents that can be used for NMR analysis. We have here also NMR tubes. So here's a tube. We will place the sample and the NMR solvent in and then cap it with one of these NMR caps. We have a very useful Erlenmeyer here. It doesn't really matter the size. It doesn't have to be an Erlenmeyer, but it's very useful for taking the NMR tube and placing it upright so that it doesn't fall over and can stay upright during sample preparation. We have some pipettes right here that we'll use for either adding NMR solvent or the liquid reagent. A pipette bulb. A very small beaker for prepping the solid for NMR analysis, and a spatula to go along with that. And then we have our unknowns. So how do we go about prepping these two samples? Well, liquid sample preparation is very easy. It involves simply taking a pipette, taking the liquid that you wish to measure, and simply dipping the end of the pipette into the liquid. And by capillary action, you will pull up a certain amount into the end of the capillary. That is generally sufficient amount of material for an NMR analysis of a liquid, and so you place that then into the NMR tube, and then taking your pipette and the pipette bulb and the NMR solvent, we can now add NMR solvent in. Now, before I do, there is a certain amount of NMR solvent that we wish to add. So we want to have about this much NMR sample solution in the tube. We don't want to have too much because that's wasteful. But we also can't have too little because the instrument won't be able to lock on the sample. And so we need to have generally about this much material. We generally use somewhere around 0.5 milliliter here, so about 500 microliters roughly. Certainly not going to measure it. You simply add this down through the pipette to wash the sample in. We will close our liquid sample here, remove the pipette, place it aside, and simply cap the NMR tube with the NMR cap. And this sample is all prepped. We would want to label it now to know which sample it is. Here I'm using a yellow cap, so I'll keep that in mind until I label it. Generally a good idea to label it right away. And then how do we prep sample for a solid? Well, with a solid, such as here, I can take this and simply take a small amount of the solid, scoop it out with the spatula, place that into the small beaker. So here you can see we don't have very much, but we also can't have too little. It needs to be enough for analysis. Seems like a little bit more than the liquid, but simply remember that the separation, essentially it's a small amount of liquid can correspond to more than a visually small amount of solid. And then from here we will take our NMR solvent and add it into the beaker. I can use the same pipette because I haven't contaminated it. I haven't touched anything else with it. But certainly I could use a new pipette. Add this into the beaker. Close my NMR solvent. Swirl the beaker around to make sure that everything, or as much as possible, is dissolved. Another trick I can use is to suck up material and squirt it back down a few times. We'll want to get as much as possible dissolved. If we cannot get everything dissolved, then one thing that we can do is we can make use of what's known as a pipette filter. So here we'll take our NMR tube we're going to prep the sample with, place that there. We can get an NMR filter, or a pipette filter actually. A pipette filter is simply one where I have taken a pipette and I've taken a small amount of cotton, stuffed it down into the bottom of the pipette, and then when I transfer material down through that, that will filter out any solid materials. Here we don't seem to quite have gotten everything soluble, and it's best to not have solid materials in your NMR tube. Sometimes you can, and the NMR instrument will still be able to handle it, but it's best not to. So we'll simply take our pipette filter, stick that down into the NMR tube. We'll take our sample, suck up everything that we can with the pipette, place it down through the pipette filter. That will then filter down through and into the material below. We can assist using the pipette bulb and push a little bit more. You can check to see whether we have enough sample, and it looks like we have just barely enough sample there to do the analysis with. And so then we simply set the materials aside. We can dispose of the pipettes in the glass waste, cap our NMR tube, label both, and we are now set to go down to the NMR room for final NMR analysis. Okay, so here we are in the NMR room. We're in front of the NMR spectrometer, which is a super-cooled superconducting magnet that's cooled by liquid helium, and then liquid nitrogen keeps the liquid helium cool. And what I'll show you in just a moment is how to prepare your sample, the NMR tube, to be able to be injected into the spectrometer. And then in the next video, I'll show you how to acquire the spectrum using the software on the computer. So what we do first is we've got our NMR tubes right here, and we have a little depth gauge, that's this piece right here, and a blue spinner shown right here.
Now this blue spinner is where your NMR sample is going to sit, so we'll place that on top of the depth gauge. Then we'll take our sample, let's do the liquid one here. We'll place that down through the spinner and push it all the way down so that I get the right depth for my NMR tube so that it will sit in the correct position in the magnet. And then I can pull the spinner with the tube out of this and take a Kim wipe and then carefully just wipe the outside of the spinner and the tube itself. I just want to remove any fingerprints, any dust, any material that I don't want to be inside the spectrometer, because it's quite a bit of a challenge to clean these out in the event that something were to get stuck inside or dirt and materials were to build up, so we want to avoid that. Now, the NMR spectrometer, and most of them, will have a reference sample that sits in the magnet itself at all times. So we first have to eject that. So I'll come over to the to the computer, tell it to eject the reference sample. You'll see that pop up here. Pull this out. Place our sample on top of the blowing air, and it will sit there now until I tell the instrument to remove the ejector air so that it can sit back down into the instrument. Now the sample will fall down and click into place. And now my sample is ready for me to perform all of the following manipulations on the computer in order to acquire the NMR spectrum. When I first open up the software, it will open up two windows. The lock window right here, which shows the lock signal, and then the actual root window here, which will allow me to do the manipulation. So for the moment, I'm going to leave the lock window alone and simply maximize the root window. And here, I now have a place where I will start, which will be create dataset. I need to have a name for the sample. And it's really important to name the file in a way that you will remember it, perhaps something that corresponds to your notebook. So a notebook number and date are very useful to help you identify when something is there. Often your initials as well, so that it can be distinguished from other students' spectra. And so here, I will simply call this, I'm going to put my initials, IAM, and then an underscore, and I'll call this unknown 6. And then I will provide the date here, which is arbitrary, but let's just say it's 6/12/21. This is probably in the future. And we'll take that as the name of the experiment. Now, here I can just give experiment number 1 and process number 1. Certainly no need to change there. Experiment type, this is very important. Proton is going to be the default, and this is for taking a proton NMR, an HNMR. But if I wanted to take a carbon NMR, I could change this by hitting the select menu here, and then a whole array of different NMR experiments will pop up. So carbon-13, two-dimensional carbon proton spectra, or proton-proton spectra, I could certainly choose, but here proton is what we want. Solvent here is very important. We have to match the solvent that's set here with the NMR solvent that we chose, so that it will, so that the instrument knows how to lock onto that particular solvent. So here, this CD3CN that is deuterated acetonitrile, we need CDCl3 deuterated chloroform. Certainly some other parameters, where do we want the final file to end up, what directory, we can just leave that as is. And then often I will simply take the name of the experiment and copy it down onto the title here as well. Hit OK. From here I can go over to the Acquire tab. And now the way that I take spectra is simply by working my way left to right across the buttons that are provided here. Now, although the particular order of the buttons and the particular display on any given spectrometer or instrumentation may be slightly different, these are still the same steps that you want to follow regardless of the particular software. So first we have a sample This allows me to inject or eject the sample. Now we've already done that, so we don't need to do anything here, but it would allow me to turn the lift air on or turn it off. So I'll move to the next one. I need the instrument to lock onto the particular solvent signal so that it knows kind of what solvent we're dealing with and is able to set up the spectrum correctly. So here I'll choose lock, and I choose CdCl3 for chloroform D, deuterated chloroform. And now I have told it to begin locking. You can see down here, and most software will put the progress of the steps down here at the bottom. So it's working its way through locking onto this particular solvent. In the event that it struggles to lock, which does happen sometimes, there are alternative commands that we can do to work around this. But most of the time, the instrument will lock relatively rapidly. So now that the lock has finished, we will turn on the spinning, because it works best when the sample is spun for homogeneity inside the instrument. So we'll turn the sample rotation on. You can hear the spinning air kick on, and then you'll see down here that will give you a spin rate. Normally we just wait a moment or two until that's semi-stabilized, frequently around 27 hertz or 26. And then we can move on to shim. Now we could certainly manually shim the instrument, but it's convenient just to auto shim. So we simply click on shim and it will undergo an auto shimming, essentially making sure that we have good peak shapes and baseline. The instrument has now finished shimming, and we will simply save the parameters essentially by hitting the Prozol button. So that reads the parameters and copies them to where they need to go in the instrumentation. Then we click gain, which sets the receiver gain, and while that is running, we are actually able to cue go, which tells it to actually acquire the spectrum. So we'll take a minute or two to set the receiver gain and then immediately move on to collecting the spectrum itself. So it has now begun that. You see it runs a couple blank scans initially, and then it will begin to collect the spectrum. 16 scans that are averaged. So now that it's collected one scan, we don't have to wait until it's completed all 16 scans to look at the spectrum. Now we certainly could. We certainly just wait until it's all done before we do any processing. But we could, in the meantime, just look, if we're curious, we can look at the spectrum. So to do that, we need to do a couple things. We need to type EFP, and this is going to be pretty common regardless of the NMR spectrometer that you are using. EFP tells it to do a Fourier transform on the raw data signal. And if I do that, then I will get a spectrum that has all of the peaks pointing downwards at the moment. So there's a second thing I have to do. I have to do APK, and this APK will do an auto phase correction on the baseline. And then it gives me my signal. Well, that's up there, so let me briefly just bring that down. So now we can see my spectrum. I can zoom in on it just by clicking and dragging. And what I can see from this spectrum, and we'll do spectral analysis here in a little bit, but the spectrum is still running. We're still acquiring scans. The way to accumulate those scans is simply to type EFP again after they have finished acquiring. And this will then collect all of them. But this allows us a quick sneak peek at what the spectrum is going to look like. So now that my spectrum has finished acquiring, I will type EFP again and APK again. And now I have fully acquired the spectrum. From here on, I can do processing. Okay, so how do I process the spectrum now that I've acquired it? Well, I can go to the Process tab right here, and I'll notice a few things. So certainly I could tell it to automatically just do an automatic processing of everything in the spectrum. Now, that might prove a little challenging to do. We may not want it to auto-analyze things. Frequently, we want to do it ourselves. And so there's a few buttons here. I would leave the adjust phase alone, unless the phasing is really bad, but that you can deal with separately. There's a calibrate axis button right here. And this is generally, we want to be able to set some signal to be at a known value. Now I've got two possibilities. In my spectrum, I have a peak out here around 7.3, which corresponds to the solvent signal. So this is a little bit of protonated chloroform as opposed to deuterated chloroform. There's always a little bit of the protonated version of the solvent present. And we could take that, I know that that should appear at 7.26 ppm, so I could simply click calibrate axis and then click on that spectrum. Another thing, however, though, is that this NMR solvent also contains TMS, which is tetramethylsilane, as an internal NMR standard, and that shows up, that's the reference that is set at 0 ppm. That's this signal right here. And so I could zoom in on this signal and click calibrate axis. Now, it should show up as a singlet, but our particular instrument here has a few issues, so it doesn't show up as exactly as the singlet. So I'm simply going to click in between those two peaks and press 0 to calibrate the axis there, and then I'll zoom back out. So after that, I will want to label the peaks. I can do this using peak picks or pick peaks. From here, as long as this button right here is highlighted, I simply have to click and drag over the peaks I want labeled. So here, and then it will label those peaks for me. I can click there and label those, here and label those. Certainly, if I wanted to, I could label the one at 0 and the NMR standard or the NMR sample, but I don't need to do that in this case. So now I've got my labels. I can simply click out of this, saving those. I want to integrate my peaks. Well, as long as this is labeled, anything that I drag over will integrate it. I want to zoom in just a little bit. So I know that that's NMR solvent. I know that this is TMS. So the three peaks that really appear to be from my sample are these three right here. So I'm going to zoom in on this region. I'm going to integrate this one, baseline to baseline on each side. It will automatically be set at 1 initially. I can adjust that later. Come over baseline to baseline on both sides, baseline to baseline on both sides. And then I'll notice that my signals are about 1 to roughly 1.4, 1.5 here. It might make more sense to calibrate this and set this to be 2. So if I right click on the integral, it'll allow me to calibrate current integral. Then I can set that to be 2, as I did, and now I have a signal that integrates for 2, one that's 2.8, which is very close to 3. In this case, it may be just slight errors in where I chose to integrate. So this should be about 3. This one, 2.9, this is also 3. So it appears that I have 2 to 3 to 3 for my signals. I can exit out of this, and now I have integrations, and I have peak values here for these. So now I've processed my spectrum in that way. Now, if I want to get a final value, I can simply do a couple things. I can do plot right here, and this will allow me then to do a little bit of preparation of the sample before printing. So here I simply click on the spectrum, and I can make a few manipulations. So first off, I see integrals here, and this curve that's showing up on the spectrum, it's kind of just annoying. It sort of obscures some things, so I'll remove it. But I still want the labels to be shown underneath the spectrum. Now I do want the peaks, and so I will click, if I click over here, peaks, I want labels, so those pop up. Initially they're too high, so I have to drag here with the green button right there. I can use the scroll on the mouse to up or down these peaks. And now I've got a spectrum where I've got peaks labeled, I have the integrations, and I'm all set essentially just to print this. So I could simply go to File, Print. and then simply set this to where I want to print it to. And then from here, I'll simply print and be able to collect the spectra and do further analysis. Once we are finished processing the spectrum, we now need to eject the sample out so that we can run our other samples, or simply return the instrument to standby mode. And so down below here, we'll go back to the Acquire tab. We need to turn the spinning air off. You can hear that noise go away. And then now we can go back to sample and turn the lift air on to eject the sample.